we are in the part 2 of the lecture. So we're going to continue from where we stopped in probability from part 1. Yeah. So what are the learning outcomes? By the end of this week, you should be able to use probability notation and the probability rules for solving probability problems, especially applying the rules for independent events and mutually exclusive events. Okay. So first of all, probability notation. So we use P of A, this notation, to represent the probability of an event A occurring. And P of A is such that it lies between the scale 0 and 1. Probability of an event A occurring is always between 0, which is impossible, and 1, which is certain, between this scale. Okay. So for example, let's take throwing the dice. Yeah. So if you throw a single die, P of 6 is probability of throwing a 6 is, what are the total outcomes? Total outcomes are 6. And there is only one way you can throw 6. So it is 1 over 6, isn't it? So I'm going to use the same formula. Yeah. That is total number of outcome is 6. And the number of ways you can get 6 is 1. So 1 over 6. Okay. Now, the probability of an event A not occurring is written as P of A prime, A slash, yeah, A prime, like this. So you write P of A prime. That means probability of A not occurring. So probability of, similarly, probability of 6 not happening is, probability of 6 not happening will be total number of outcomes. Again, it will be 6. Number of ways 6 will not occur. 1, 2, 3, 4, 5 ways. There are 5 ways that 6 will not occur. Okay. So you have probability of 6 prime is equal to 5 over 6. Good. Now, so we have seen that probability of, if you throw a single die, P of 6 is equal to 1 by 6, P of 6 prime is 5 by 6. So what is probability of 6 plus probability of 6 not happening? Probability of 6 happening and probability of 6 not happening is nothing but 1. Yeah. So that's our first rule. Yeah. In general, P of A plus P of A prime is 1. Yeah. The sum of probabilities of all possible outcomes is always 1. You can rearrange this in this form. That is P of A prime is equal to 1 minus P of A. And this is called complementary rule. Okay. This is called complementary rule because P of A prime is a complement of P of A. Okay. Now, when one event doesn't affect the probability of a second event occurring, we say they are independent to each other or they are independent events. So probability of both events occurring is equal to probability of first event occurring times the probability of second event occurring. This is what we saw in the part 1. Yeah, we saw that in the part 1. Okay, so we can use the probability notation now and then say probability of A intersection B. Look at that. When you have both event occurring, that is and. Okay. So probability of A and B. Probability of, and let me put this and. Probability of A and B. A probability of A and B occurring is probability of A and B occurring is, that is A and B. The bracket has gone back. Is probability of A times probability of B. However, when one event does affect the probability of a second event occurring, yeah, the good example for this was throwing a coin, isn't it? But if any occurring of an event is affected by the previous event or the occurring of an event is affecting the occurring of the second event, then P of A and B occurring is equal to P of A times P of B such that A has already happened. Okay, so that means now It is not just P of A times P of B. It is not simple because probability of B happening depends on A. Okay, so this is conditional probability, just like the example we saw in the last part. That is picking a ball by not replacing, without replacing. So this is an example of replacing, and this is an example of without replacing the ball. That is, if you pick the second ball, the picking of the second ball is affected by the picking of the first ball, because the probability is not P of B anymore. It has changed. You saw that. You saw that without replacing, the probability changes. Yeah. So this is called conditional probability, isn't it? So this is how you represent mathematically for conditional probability. Yeah. Probability of B. And how do you read that? Probability of B, event B occurs given that event A has already occurred. That is, probability of an event B happening such that A has already happened. Given that A has already happened. Okay. So that is the conditional probability. Yeah. So be careful with the two formulas. Okay. They're different. One, here B is independent of A. Here B is dependent on A. That is why the probability has changed. Okay. So now let's go to the formula. Yeah. So we use notation to represent the probability associated with two events. Here we're talking about event A and event B. So we have A intersection B and A union B. Okay. Okay. So probability of A intersection B is equal to probability of A times probability of B, given that A has already occurred. AS has already occurred. So that means probability of B is now being affected by A. Okay, this represents the probability of an event A and B both are occurring together. Yeah. Now, this is called conditional probability. Using this mark is called, because B is affected, probability of B happening is affected by A happening. Okay, now this rule is called multiplication rule. Okay, I can write the multiplication rule also like this. If we have two independent events, yeah, when we have two independent events, I can write the same thing as P of A times P of B when I have two independent events, P of B. But in this case, it's not independent, okay? That is why I have this conditional probability. So we can have events of this type or events of this type. That is when A and B are independent of each other, like tossing the coin, or when happening of A is affected by B or happening of B is affected by A, okay? Okay, this represents the probability of at least event A or event B happening. That is, or is usually represented for plus, yeah? So probability of A plus B minus probability of A intersection B. And this is known as addition rule. So you have two more rules here: complementary rule, multiplication rule, and addition rule. Now three rules. You have three rules. Okay, I'm going to write these three rules in different ways. Okay, I'm just writing the complementary rule here and the addition rule here, and I'm just, look at that. This multiplication rule, I have just kept this on the left-hand side and moved everything down. So that is your multiplication rule. So complementary rule, addition rule, and this is your multiplication rule, CAM. Okay, so you got the three rules there. Okay, so that's your complementary rule, addition rule, multiplication rule. Okay, not erasing that. Yeah, so let's do a little problem, a small problem, to understand the rules of independent events. Okay, I have here probability of B and even B occurring as 1 by 3, and a probability of A union B is 2 by 3, and probability of A intersection B is 1 by 6. Now, what I want you to do is use the rules of probability and find P of A and P of A, given that B has already occurred. Good, that's right. So what did you do? P of A, use the second rule. Yeah. And then rearrange this. So you have P of A union B. Yeah. P of A union B minus P of B. Just rearranging that, plus P of A intersection B. Okay, I'm just rearranging the addition rule to get P of A. Okay, and then what do I just substitute everything. P of A union B is 2 by 3 minus P of B is 1 by 3 plus P of A intersection B is 1 by 6. So this is nothing but 1 by 3 plus 1 by 6, or I have 2 by 6, so 3 by 6. So it's nothing but 1 by 2. Now how do I do this? I rearrange, use this formula, but in this case, A is the first event, B is the second event. This formula is for B as the first event and A as the second event. So what I'm going to do is I'm going to rearrange it such that I have P of A intersection B. A intersection B doesn't matter because it's the intersection of A and B divided by P of B. I just rearranged it because I have now A as the first event and B as the second event, not like this. Here B is the first event, A is the second event. Anyway, so what is A intersection B? 1 by 6. And what is probability of B? Is 1 by 3. So what do I get? I get 1 by 2. Ooh, look at that. So P of A is equal to P of A such that B has already happened. Doesn't matter if B has happened, both probability are same. It doesn't matter, B has already happened. P of A, such given that B has already happened, is equal to P of A. Both are half. So it doesn't matter if B has already happened. Okay, so that means I can say that P of A, given that B has already happened, is equal to P of A is equal to half. So event B doesn't affect event A, and hence event A and B are independent of each other. So in general, when two events are independent, then you have A, given that B has already happened, B, probability of A, given that B has already happened, is equal to probability of A. Probability of B, given that A has already happened, is equal to probability of B. It doesn't matter whether this has occurred, it doesn't matter whether this has happened, they are equal for independent events. Similarly, the multiplication rule just becomes simply the same probability because it doesn't matter. Okay, now let's see the mutually exclusive events. Okay, so we have some example here, and you have to use the rules of probability to find A intersection B. Good, very good. So what did you find? A intersection B. Which rule did you use? Yeah, because you have given A union B is given, A is given, B is given. So you can use this to find. So this is equal to A intersection B 11 by 12 minus 2 by 3 minus 1 by 4, which is nothing but 11 by 12 minus 11 by 12, which is 0. Yeah. So what do you get? Probability of A intersection B is 0. Both events happening is impossible. 0 means impossible. So probability of A and B occurring is impossible. That is mutually exclusive. So we can say that when P of A intersection B is 0, the events A and B cannot occur together, hence they are mutually exclusive. Okay, so in general, when events A and B are mutually exclusive, one prevents the happening of the other. And the condition is nothing but, if you can prove that P of A intersection B is 0, that means the two events are mutually exclusive. Or if we can prove that P of A, given that B has already happened, is 0, then the two events are mutually exclusive. Then if you can prove that probability of B, given that A has already occurred, is 0, then the two events are mutually exclusive. So that's the condition for mutually exclusive events. Okay, now next. Now here we have a 2 by 2 table. Yeah. No, sorry, not 2 by 2, 4 by 4 table. Yeah. Or we can say two-way table. That's better to say. Yeah. Two-way table relating to the treatment of a medical condition in 72 patients at a doctor's surgery. So how do you read this table? You can see the total patients in this corner. Okay. So you would have used it in biology, isn't it? Two-way table. Yeah. Okay, so you have the total patient 72. Assume one patient is selected at random from 72 treated. Okay, you have to pick one patient at random. That means there are equal chance. Each and every patient has an equal chance of being selected because it's a random process. Look at the word random. So each and every patient has an equal chance to be selected because it is a random process. So now what I want you to do is find the probability of male, find all these values, okay? Find all these values. Don't forget to remember to use the rules of probability, okay? The three main rules: complementary rule, multiplication rule, and the addition rule, okay? Remember one more thing, this is not the same as P cured intersection male because this is a conditional probability. This clearly says that you have already picked a male and now you have to see what is the probability that the male you picked is cured or not. That's the meaning of this. You already picked a male, you've already selected a male patient, and what is the probability that the selected male patient is cured or uncured? Okay, good. Okay, let me just rub this all. Yeah. Okay, let me go back here. What is the probability that you will pick a male? The patient you picked is a male. What is the probability that the patient you picked is a male? Yeah, it is, total outcome is 72. Out of 72, there are 36 ways you can pick a male, isn't it? Sorry, not 36, so 36 plus 12. 36 plus 12, yeah? 48 ways you can pick a male, so 48 out of 72. You have to simplify this, so you get 2 by 3, yeah? Now, next question. What is the probability that the patient you selected randomly is uncured? So you have how many uncured patients? Look at that, not cured. It's 15 out of 72, isn't it? Total patients is 72, so 15 out of 72. Okay, you can reduce it further and you get 5 out of 24. Now, what is the probability that you pick a male and the patient is cured? You pick a male and the patient is cured. Okay, so that's 36 by 72. Now, what is the probability that you pick a male? This is union, okay, cured. Yeah, you pick a male, union, cured. So here I would suggest you use the formula. Okay, I would suggest you use the formula. This formula, addition formula, okay, addition rule. So that means it is male union cured is nothing but probability of male plus probability of cured minus probability of cured intersection male, this one. So you just can, probability of male, you have already found. Probability of cured intersection male, you have found, but you haven't found probability of cured. What is probability of cured? 57. There are a total 57 patients who are cured. So 57 out of 72. Okay. So you add them all and subtract it with the intersection. So 48 plus 72 plus 57 out of 72 minus 36 out of 72 is equal to 69 out of 72. Okay, now the last one, be careful, this is conditional probability, so use the formula. Okay, and then you can substitute. You already found P of A intersection B, male intersection cured. And you have to, what is the first event here? This is your first event. You have picked a male patient. What is the probability that the patient the male you have picked is cured or not? That is your second event. Okay. So probability of A intersection B is 1 by 2, and probability that you picked a male is 2 by 3. And so you solve this. That's your answer. Good. So we'll do more such problems in the seminar because it needs lots of practice. Yeah. Okay. So now you have seen how to use probability notation and the rules and how to apply them for independent and mutually exclusive events. Okay, thank you guys. That's all for now.